Click the bell icon to get latest videos from Ekeeda.
Well friends, in the previous topic we have discussed about the numerical based on the decay constant problem number 9, and here basically we are going to talk about the problem number 10. So what is the question and what is the answer we could get after understanding it? Let me talk about that in this. So friends, this is the question that is what we have, that is what will be the approximate time taken for 90% decay of iridium 174 in terms of its half-life. So here basically the detail that we could get here is, since they are talking about what will be the approximate time, that means they are asking for time that is being required for 90% of the decay of iridium 174. If 90% is been given, obviously suppose we could say that is the initial amount or the initial concentration for the iridium, suppose it is 100, it is 100%, suppose it is 100, and after 90% of the iridium has decayed, that means the amount that is left of iridium, it will be nothing but N, which is 100 minus 90% which has been decayed. So therefore we have got the value as 10%, or we could get the value of N0 as 100 and N as 10. But here we have to calculate the time also in terms of half-life. So for that we have the formula, that is T half is equals to 0.693 divided by lambda. So let's see that how this equation is very much relevant to get the particular answer of this question. So friends, as we know, that is for half-life, we understand that is T half is equals to 0.693 divided by lambda, or else we could say that is lambda is equals to 0.693 divided by T half. So now let me make this as equation 1. And also we know that is the decay constant, that is lambda, has a formula, that is lambda is equals to 2.303 divided by T log to the base 10 of N0 divided by N. Let me make this as equation 2, or let me think that what happens if we substitute the value of lambda over here. Once if we substitute the lambda, the value of lambda, that is equation 1 here, then we could get the term as T half, and then we can easily solve this question. So let me substitute the equation 1 here, so therefore we could get that is 0.693 divided by T half, which is equals to 2.303 divided by T log to the base 10 of N naught divided by N. Since we need the time or the approximate time that is required during the conversion of 100% of the iridium to 10%, so let me substitute the values over here and let's see what is the time that we would need in terms of its half-life. Therefore the above equation could be written as, that is T is equals to 2.303 into T half, the whole divided by 0.693 log to the base 10 of N0 divided by N, and in that case the value of N0 is, or N naught is 100 divided by N, which is 10, which makes this to have a value of log 10, and log 10 has nothing but the value of 1. So what we have is, we have 2.303 into T half into 1, the whole divided by 0.693. So now let me calculate this too, and let's see what is the value we could get. So therefore we have got the value here as 3.32 into T half, and that's it. So this is the time that is what we have got in terms of the half-life, and that's it. Thank you friends for watching this video. I hope you have understood this numerical very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.